In this video, I'm going to give you a nice simple explanation of how buffer solutions work. So let's start with a beaker. And this beaker contains a solution, and this solution has got some universal indicator in it, and it has a pH of around about 7. It's neutral. We take some acid, as represented by some H plus particles. That's our particle for an acid. We add those H plus, which represents adding an acid, and unsurprisingly, the solution would turn a kind of red color. So universal indicator is indicating that we now have an acidic solution. That makes sense. We start with our same solution with some universal indicator in it, turn green. We take some alkali, which is our OH minus. We add that, and unsurprisingly, the color of the universal indicator would change, and we would end up seeing that we have an alkaline solution. However, if we had a solution with a buffer in, things are going to be very different, and it's going to behave a little bit strangely. If we took some acid, and I mean a little bit of acid, not an enormous amount of acid, just a little bit of acid, we add a little bit of acid, and that acid goes into the solution, and nothing happens. We could take some alkali, add some alkali to the solution, and again, nothing happens. This is the magic of buffering. We've added an acid, the pH hasn't really changed. We added an alkali, the pH hasn't really changed. That is the point of a buffer. A buffer can maintain a solution at roughly the same pH and resist the action of acids or alkalis that are added, but it only works up to a point. If you added an enormous amount of acid or an enormous amount of alkali, it wouldn't keep working. And the question now is, what is going on here? How is it possible that you can add acid or you can add alkali and not be changing the pH? That is very strange. And it actually turns out there is two things going on here. One of the things deals with the acid and one of the things deals with the alkali. So you actually have two main ingredients in a buffer solution, and we'll look at what each one is and how each one works. So we have our solution here. One of the two components of our buffer solution is going to be a thing called HA. And the question is, what is HA? What is this key component? And it turns out that HA is simply the name of a weak acid. So any weak acid can be represented by HA, where H is obviously hydrogen, which is a key part of an acid, because you need to have H plus particles, and A simply represents whatever else you need to add to H to complete your weak acid. So it could be an acid like ethanoic acid, or it could be a wide range of other weak acids, say benzoic. So HA is just how we're going to represent any weak acid, and that is one of the two ingredients of a buffer solution. So we have an equilibrium going on here. So we have a weak acid will dissociate and it will produce H plus and it will produce A minus. So this is splitting up. A minus is what we call a conjugate base. The equilibrium, however, isn't a fair equilibrium. It's not half and half. The equilibrium is very, very much towards the left-hand side because this is a weak acid. Weak acids partially dissociate. So most of the HA is going to be undissociated, and you're only going to get very, very few H plus and A minus. The vast majority is going to stay as HA. So that's why adding the weak acid isn't going to immediately turn your buffer solution into, going completely red and being an acid in terms of pH. So let's look at how this actually works in practice. So we have our solution there that's buffered, and we know that one of the components of a buffer solution is our weak acid HA. So let's think about how would HA react if it was exposed to some alkali particles, so some OH. Well, what happens is your weak acid reacts with your OH and produces water and your conjugate base A minus. Now, this is, of course, alkaline because OH minus is your alkali particle, but water and your conjugate base, this is overall going to be neutral. This isn't going to be alkaline. So what happens when you add your base, which is your OH minus or your alkali, you add that there, it's going to react with your HA, which is your weak acid. These two react, and of course you get this produced, so they react together, and you end up with this. This isn't going to change the pH of your solution very much, and you're going to end up with a pH that's virtually unchanged. Of course, if you added an enormous amount, an absolutely enormous amount of OH minus, it would absolutely overwhelm the HA. You would run out of HA and it would no longer be buffered. So buffers only work up to a point. This is how you deal with OH minus or your alkali. What if we added an acid? Well, this isn't going to work. We're going to need to add another ingredient. So we've got some acid particles there. We want to add these. And obviously, there has to be some sort of reaction that gets rid of these. Now, we know there's this equilibrium here, which we've seen earlier. This A minus could, of course, react with this H plus. But remember, this is a weak acid, so we're not going to get very many of these. These are going to be gone very, very quickly. So simply having HA as the only ingredient in a buffer isn't going to work because the equilibrium's far too far to this side, far too few of these. So the trick is to add a soluble salt of HA. So for example, we could have NaA. So whatever A is, we could have sodium of that. Now, we have this reaction here, which is NaA fully dissociates into Na plus and A minus. Na of A is going to be a strong base, so that's why I've showed it with this arrow, showing that it fully dissociates. Because it fully dissociates, we're going to get loads of A minus. There's going to be loads of A minus floating around. So we've actually got loads of A minus. This is minus, this is plus. Unsurprisingly, there's going to be a reaction between those. So those two react and you end up making your HA again, which is one of your ingredients of your buffer solution. And the HA is, of course, a weak acid, so it's going to only partially dissociate, so it isn't going to have very much effect on the pH. It's going to have a little effect because you're going to have some H plus produced, but it's not going to be a very big deal. So a buffer can maintain the pH between very narrow values as long as you don't add enormous amounts. So you've seen our two components of a buffer solution are your weak acid and the salt of that weak acid. So you now know how a buffer works. I hope this video was really helpful to you and it's finally making some sense. If this video did help you, please comment below and let other people know that this video is helpful to them. And if you like it and subscribe, that also encourages me to make more videos and suggests that this is actually helpful. And finally, thank you very much for watching.